Uh, Hello, everyone. It's nice to see you guys all again. Got a good contingent here this week, so I'm excited to get everybody back and get into it. Again, if you'd like to talk about anything as far as agenda, Lindsay, I'm not sure if we're ready to talk about governance yet. It might be a good time as far as agenda items for things today. If not, we've also got some, I was going to host some coding things afterwards, so my thoughts is I'd like to, some of you, Dita, if you guys are around, I'd just like to pick your brains a bit about some EM1D stuff. Does anybody have any other agenda items or things to chat about for the meeting? Those are at least my 2 thoughts on things. Now we can go through some. Go ahead.
Yeah, I probably wanted to pick up what we had the discussion this week in general, I think, about the inversion that is used and which is used. And I talked to Sogi about it and said maybe it would be cool if, I don't know, Lindsay, Dom, Sogi, I don't know who are the main contributors to the inversion. Once could give like a session on how does that work and like a Q&A or something. And Sogi even said we could record it and put it online for folks that cannot attend or later.
Yeah, I think that'd be a great idea. Like I know there's still a lot of stuff in there, like you were talking about, like why does it skip BFGS sometime? Also, why do we care? Like, right, some good questions there, just some good things to get out.
Because then I looked a bit in the API docs or the examples, but I don't think there is awfully a lot to find except reading the code, right? Or did I miss something?
No. Well, that would be great, Dieter. I'd be happy to work on that. And Sagi, if you're interested, we could work on something together, and anybody else. And maybe we could actually first get a few questions from folks, and that can maybe focus what we give an overview on. I could, so in some ways, actually imagine this going, coming in 2 parts. As one is kind of the inversion components of SimPEG as they are. And I think that will rapidly lead into a discussion of the inversion components as they should be. So, but I think we should decouple those because it's worth
Shall
talking
I make a discourse issue and we could collect ideas there?
Sure, that would be great.
Cool, I will do that.
Cool. I'd just like to say that we can go to some quick reports before we start talking more about the agenda and other things. See, I added a few things to GeoAnna that were kind of necessary for the more EM1D stuff, like things like adding primary functions for static receivers and things like that, or static sources. It's tested, so I'll probably pull that in quickly. And then I'm just working through the time domain part of the EM1D functions, just a little bit of things here and there to clean up. And it's about ready. I'll probably have a pull request onto the EM1D bench so you can see everything that I changed. Look through it. It should hopefully a decent amount of cleanup happens to it. It should be much more SimPEG-like. And then, like I said, after I was just hoping to chat through some stuff later today about how we can use like the transform functions with Dieter's EMPI mods together with like the like trying to do convolution in that domain instead of how we're doing it currently in that function in that module. Because right now, Sagi, correct me if I'm wrong, but it essentially does the convolution in the time domain after it's done. Like it computes it in the frequency when you're doing arbitrary source functions. It does the convolution in the time domain, and that's about. It's not nearly. It's not as efficient, from what I understand.
It's correct. Like, but it has somewhat 2 steps. So you first do a convolution to get the step response, and then convolve. So it's kind of 2 kind of convolution, I guess. Well, so actually the convolution is only happening. So I think that getting the step function is not necessarily a convolution, I think. It's just a transformation of frequency to time. And then we do this like a convolution. And if you're actually interested in, I think how UBC does, like UBC code does, is actually better. It uses the spline interpolation to evaluate that convolution analytically. So this was on my to-do list, but yeah, I think I got something still analytic, but it's piecewise analytic, so it's okay. But I'm pretty sure like implementing the UBC way would actually be quite better, and by doing so, you can actually handle the on-time response, which is coming in these days, especially for SkyTim system and maybe a couple other systems. So it would be quite nice.
I'd like to just get it in and just get it like that. So it's general and it can handle that. It's not as just kind of getting in terms of that way, it makes it a little bit easier to program in general, because you don't have to, if you can be more general with that convolution there, right, you don't have to have nearly as many special cases. Look at the times from ends or doing other these, you know what I mean? Like it's a lot of ungeneralized things.
And
so
and that's something that you could think of, like even for a PDE code. That's actually what I locally worked on, basically updating the first order, backward order to a second order, and actually doing that kind of that numerical convolution after you get the step response actually simplifies on the user end. So now at that point, if you can come up with a good time steps that can work for all the cases, then what the user need to put it in is just the waveform and where the time gates are. That sort of solves kind of this complicated problem, how to set the time steps accurately to get the good response. So this is a potential a pathway that we can think of that complicates the inverse problem, but at least for the force sense, it's actually nice.
Yeah, and the way that I'm looking at doing it right now, it doesn't really complicate it any much more. I'm just trying to I go through and then, I mean, it's not that expensive to generate a spline or something and then generate the linear representation of that spline, or the linear matrix representation of that operation. So we don't have to mess with like forming all the splines. You just represent it as a matrix times a vector and then move on. So it wouldn't really complicate it too much more. Anyway, so that's what I know my quick reports. I see John had added something on there.
Yeah, I was working on the MTPR, but then I kind of put that down, got distracted with the tiling. Yeah, I did a bunch of tiling tests on the cluster for small problems, just normal synthetic models. But then as I've moved into more of our recent projects where we have like over 5 million cells into a model, the RAM is just adding up so quickly. You make like a few tiles and sure, the sensitivity matrix is being stored on the main machine, but it's just calculating the fields and like still having like a 2 million mesh on every tile. It adds up pretty quick. So yeah, it's really important, I think, right now to have the octree mesh and doing the the nested octrees. The other thing that's working against me right now is everybody who's doing inversions in Vias right now wants tensor meshes. So I'm doing a global tensor and that's killing me as well. So yeah, just trying to deal with the RAM. Oh yeah, I did some subtiling there, Dom. Again, I was trying it on one of our recent data sets and it's just too much RAM. So I'm gonna have to make up a little synthetic model to test further. Otherwise, it's just, as you keep creating those tiles, it's just more and more RAM because it's got to make its own model for each one of them, and that seems to be the killer right now.
Sorry, what method are you looking into?
The tile, or sorry, that would be the tiling by frequency and by space.
So MT.
Yeah, using the MT code. Yeah.
Yeah. Yeah, we need to look at a way to just store the inner product, how to build the inner product, but not store the mesh, right? So we just need to store the operators.
Yeah.
Instead of storing the trees.
Actually, I remember you mentioning that before. Yeah, I think we're right at that point now.
We did it for DC, right? Where we just need to do the same thing for
oh, okay. Yeah, I'll take a look at that and see if I can translate that over.
Yeah, yeah. You're basically storing on your simulations only the operators that you need, and then you ditch the mesh right away after the tile is created.
Okay, nice. Yeah, I'll take a look at that. Other than that, that's all for me.
Okay. Devin, you guys added something.
Yeah. Basically, I've just made a bigger dent in the docstring stuff for discretize. So continuing to put in some work there. I'm not exactly sure what the time frame for a final draft of all that is, but I would hope in a week or two. That's about it.
Is that all on like a local branch to your computer? Or even pushing it to?
Yeah. Where is it? I just gotta. It's on the same branch I've been working on before. I noticed that you've been making some changes to that repo as well, so I want to make sure I'm up to date. Yeah, it's my branch is NumPy docstrings API. And then I see that you've been working on PyData retheme.
Yeah.
So yeah, I think I was just I was pulling your branch and merging it with mine because you were basically going to be finished that before I was going to be finished this. I think that's what the idea was.
Mm-hmm.
So yeah.
And it's like if you don't, I mean, I can look over it too while you're in the middle of things if you want to like do that as well, so you don't have to wait until the final draft to have it reviewed or anything.
Can you repeat that?
If you want, I can like look over some of the things already that you've added, just kind of like, oh, catch a few things here and there for other stuff going forward.
That could be done soon. I think there's a couple questions that I have about the level of detail I want to describe some of the base mesh classes, because those are so general that I don't want to make the description of what that functionality is very specific to the coordinate system and things like that. So yeah, that would be pretty useful.
Okay.
And then yeah, some things on the level of detail that we want for the operators, describing the operators, because it would be good to have some kind of image in there and actually show like a mathematical definition of this is how we compute the the derivative in the x, and it goes from say faces to cell centers or something. Okay.
Yeah. Okay. Okay. Are there any other quick items that people want to update on items over the week? Now we can probably move on to some of the agenda items. Hearing no objections. I mean, Lindsay, if you're good to chat through some governance stuff and give kind of, and hopefully we can make some steps forward. I mean,
yeah, sure. Thanks for bringing that forward. I think the biggest ask right now is if folks can take a look at the pull request that's on there right now. I see both Dieter and Soggy have. It would be great to just see, I'll just drop it in the chat there and I'll put it in the notes here too. Just to see some sort of indication. I mean, if you've got any suggested changes, that's great. Feel free to make some suggestions. If you're happy with it, it would be great to see just indications from folks that sort of you're on board. So if you don't mind just leaving a comment or giving a thumbs up or something like that, just to indicate a bit of community consensus, I think is important to show that people in the community have looked at this, and it's not just sort of three of us who are like, yep, this is the SimPEG governance. So if you don't mind sort of giving a bit of an indication of just if this works for you, and if it doesn't, feel free to raise questions and thoughts and ideas there. And so we can sort of put a check mark on that and move on towards the next things. Which I think what we should start looking at is, I think I've got a couple, or I haven't written those down too much yet. But sort of some steps forward, I think, we want to think a bit about, we've talked about sort of website updates, things like that, that we might want to be including to highlight visibility of folks in the community and contributions from multiple institutions. But also showing, collecting papers and collecting places where SimPEG's used in a sense to track some of our impact. So I think that's something that I would put relatively high on the priority list. But I would love to hear if there's other things that you think are also kind of high on that list of what we should really be prioritizing for the next sort of step with governance.
Sounds good. I mean, I know it's been sitting there for a while, so it's like, let's take some time this week and look at it and read through it. And I would say I'd like to get it approved next week if that's possible. Like, it's been there for a while. Just take a look through it.
That sounds good. We can plan to hit the merge at the meeting if that works with folks. And if you do have questions, concerns, thoughts, if anybody wants to chat about this, more than happy to. Yeah. And then feel free also to, if there are things that you think should be prioritized, I know we sort of just put this on the spot, but to open up issues in that repository. So I think for me, the main things that come to mind are the website that we mentioned, and also starting to perhaps come up with a bit of a strategy for sharing and communicating and planning, sort of a bit of a roadmap for the next sort of larger pieces of what we're going to work on within SimPEG. So those for me are kind of the two main things that come to mind. But if there's other things that you think should be prioritized, or that even if you don't think it needs to be prioritized, but it's something we should be thinking about, feel free to just open up some issues there, and we can use that repository as a bit of a place to track ideas and aspects of the community.
It's better to do it as issues, Lindsay, if we want to say propose plans or like items to tackle, just create issues on those.
So are you thinking like development plans at this point?
Yeah, we were talking about roadmap, right? So
yeah, I think the first step there is to figure out what we want to do for the roadmap, and maybe that is a good place to do that as issues. I'm almost wondering if the first step there, or if we want to create like a roadmap document that we would then sort of create pull requests to. But you know what, right now, if you've got ideas in mind for roadmap items, let's track them as issues, and then we can sort of figure out from there, like what's the best way to kind of consolidate all of this stuff. But yeah, let's get them down. And so if an issue works, that's great. Or even if you want to draft it in a Google Doc and then just link that in an issue, that's fine too. But yeah, unless anyone has other preferences or suggestions, an issue seems like a reasonable place to do that.
And have a roadmap issue, and then people tag their comments, and then we compile it all, vote on it.
Yeah, that sounds good.
Okay. Well, that's good. Let's make some steps forward towards that. Are there any other items, outstanding items people would like to chat a little bit more about? Do we want to, Dieter, do you want to set a time for that Q&A? Do you want to try to get what sort of time period are you thinking about it? Or do you want to do that? Can we set that up afterwards at some point?
No, I thought I make this discourse issue. We can post there maybe a week or two, and then,
Right.
I mean, it's gonna basically Lindsay, Sogi, whoever is working on it will have to say when they have time. But
Okay.
maybe if there is a short meeting like today, we could do it afterwards, half an hour meeting, and then do this session, or yeah.
Okay, cool. Is there anything else? I know I like keeping the meetings short.
If anybody else has nothing, I met up with Nick and other people from Barrick about the CSAMT data. So this was kind of ignited of hackathon between myself and Peter. So we kind of implemented the JVAC and JTVAC in the SimPEG side using the EM Python as an engine. So I was looking for a good large scale
EMG3D
version.
The 3D code.
EMG3, not EM Python. So I got one data from DAC about what Mike McMillan did in San Antonio. Not San Antonio, that Antonio deposit. And that'll be, I haven't inverted, but I'm just collecting the data. But what we are going to get from Nick and Barrick seems quite interesting. So, and also it was good to chat what were the challenges that they have. So the typical tool that they are using currently is a 2D MT code. And so you can still fit the data well, but their confidence is very low. So they get the result, they spend a lot of money to collect the data, but still the confidence about the result is very, very low. And I asked them, okay, but all of you actually got the UBC code that you can actually invert for. And they actually kind of explained the history of inverting the CSAMT data. I think they asked Mira to do it. And I think it was a long time ago when they were using the EH3D, which is very, very old version of the UBC code. And the challenge that they had was that sign changes and this phase changes was not consistent. So I think at some point they gave up. And then they tried with the latest code, but somehow that was also not successful, which I wasn't exactly sure why that was the case, because I didn't see any problem. But I think potentially the form of the data they had to deal with was not kind of consistent, because what they provide sometimes is not electric field and magnetic field. It only provides apparent resistivity and phase. And sometimes the phase information is wrong. So I think that all these technical challenges kind of made them hard actually to run the 3D inversion, even though they have the good code. I think that's where they are. And what's actually interesting, a lot of the historical data set doesn't know where the source locations are, but they do have lots of historical data that can potentially be used and re-inverted using the latest code. So I asked them if we can actually kind of revisit this problem and make it possible to re-invert all data as well as the high quality latest data. Then it seems like it's quite impactful, because what they really want to do by using the CSMT, they want to go a little bit deeper than DCIP. So like the maximum of DCIP is 500 to 700 meter or maximum kilometer. But by doing CSAMT, they can go a little bit deeper, like a couple of kilometers, or maybe even a kilometer is actually pretty good. So it seems like a timely topic. So anybody interested, yeah, let me know. I'm happy to. It's my nobody's paying me. So I'm just doing my own and my own interest and volunteering to do so. But I think there are some potentials, I think. And if you actually do it right at this point, I think that could be a really useful tool for the society, I think. So anyway, that's where am I. And I submitted an abstract to this, what Lindsay is convening, and we accepted, Dieter, congratulations. So we're gonna do something by then. It's August 21st. So we're gonna get some result about the CSCMT by August 21st. So anyway, that's where am I. And anybody, let me know if they're interested.
Yeah, I'm sure Scott would be very interested in this. FYI, Nick is no longer at Barrick SUG, right? So you'll need to talk to Lee.
Yeah. So that was why Nick bringing in Lee and other people.
Okay. All right.
So they measured CSAMT without recording the source.
I think probably they did at some point, and then they lost, I guess. And also, I think that's because of the tool. So you use the 2DMT code, which doesn't require any source information. So I think it's kind of odd situation where interpretation tool limits the design of the survey as well as the recording of the data.
Yeah, interesting.
Hey, Soggy, I have a data, I think I mentioned this a couple meetings ago, but we got a data set where we've actually recorded the source, and given what they found in the background, it should be considered a near source, or yeah, I guess a near field, I guess it is, yeah, near field solution. So if you're interested in to do a test to see, like, if you have the source and if you don't have the source, how much it changes, I'd be into that. I will be touching down on that eventually, but I don't know when. But if you're interested, yeah, drop me a line.
That's good. Thanks, John.
Okay then. If there's anything else?
Yeah, I might add just one thing or two. Yesterday, there was like a short talk at the CAEX to like a PhD student from Laurentian doing like some sort of regional and local MT inversion in the Abitibi and the Archean belt, and he was using ModEM for his inversion, but like it was mentioned during the talk that he was kind of limited by the mesh in ModEM, and that like I'm not sure how good his coding skill was, but he was mentioning that like he would have loved to have access to the Octree MT code of the UBC, but that's behind the paywall and the consortium. But just to mention that there is definitely a need for people out there for like the MT Octree code, maybe with SimPEG. So just wanted to mention that I was part of the discussion, like the access to efficient Octree code was part of the discussion, because like his thing was that he had like some sort of like the regional course MT station, and in some area wherever he can put it, because that's kind of like a very bushy area. So he was mentioning that field is kind of complicated, but like in some area he was trying to have like a finer finer station. So he was kind of looking at this like regional, and then looking at the local one, starting and constraining with the regional, but he was limited in what he could do with the mesh. So Octree was kind of part of it. Yeah. Maybe that's very minor too. I haven't checked, but I just realized that somebody, like maybe Joe, you saw that somebody on PyMath Solver mentioned that PyMath Solver was not working for him with MKL 2021, and I just checked for myself, and I'm actually working with MKL 2020, so I'm not sure if it's something, or if that was just this person issue. But I just did you see that?
Yeah, I saw it. I haven't looked into anything more with it. I think it might have something to do with a form, like a change in the way that they're pushing, like printing out the MKL version. But I haven't looked into it too much. And I just kind of Googled it.
Yeah,
Change it, like the changes between them really quick and test. I was guessing it might have been that.
How do you check your version,
Okay.
Thibault, for PyMKL?
I went the very dumb way. I just typed conda list, which lists all of my package, and I looked at conda like that, at which MKL like that. And I'm working on 2020.4. And the issue that was posted on PyMath Solver is for the 2021 version.
SimPEG report will probably also report on it.
Yeah, right.
0.0.3. I don't know what the I think that's a conda thing, right? The 2021. Because
Yes.
even their pipe on PyPy it says 0.0.3. So I don't know.
Yeah, I know you need to look on conda for that.
I think there is a way to get it from PyMKL though. I think there's a way to get the MKL version from there. Something to look into. Okay, then with that, I guess I can stop the recording and then move on to some other peep and other items and chat through some things. Thank you guys all for coming. If you need to head out, I'm not stopping you.
Hi, sounds good. Have a good one, guys.